In question F, we're going to graph this rational function. Now, there's lots of pieces to rational function, and we only need to show specific ones to be able to graph this. So the very first thing we're going to do is we're going to factor this. And so I'm going to factor the numerator. So it factors into x plus 4, x plus 3, and factoring the denominator, we end up with x plus 5, x plus 3. So we want to establish the restrictions. Now, the asymptotes are going to be based on the factors that do not cancel. So that factor there, x plus 5, doesn't cancel. So my asymptote is going to be ending up at x is not equal to negative 5. I'm just going to draw in a vertical asymptote at negative 5. The whole happens where the factors cancel. So x plus 3's cancel. So the whole occurs at x equals negative, or x is not equal to negative 3. So we're going to end up with a hole at that point. So when we draw this in, we need to make sure we draw a hole wherever the negative 3x value ends up. So these are the restrictions. These are my restrictions, not equal to negative 5, not equal to negative 3. One happens to be a hole because it cancels. The other happens to be an asymptote because it doesn't cancel. So when we graph this, we should look for a horizontal asymptote. So the horizontal asymptote will be based on the endpoint behavior. So as x gets really, really big, the plus 4 and the plus 5 really become insignificant. So we end up with a ratio of 1 to 1, x over x in the numerator. And so I can draw a horizontal asymptote at x equals or y equals 1. And this is only endpoint behavior. This is only what's happening at the very ends of this function. Now we can cross this all we want. The vertical asymptote we cannot cross, but the horizontal asymptote we can cross. They are very different from each other. And the green horizontal asymptote only is what's happening way as we get way out in the extreme values. So this is what we call endpoint behavior. We can get from this equation, we can get, let me choose a different color here. Let's choose purple. Okay, for that equation then, we can get zeros. And the zeros come from that. So the zeros are the zeros in the numerator. And in this case, the zero is going to happen at x equals negative 4. So at x equals negative 4, I'm going to cross the x-axis. Now at this point, what we can determine is that we're going to have graphs in these quadrants here across the diagonals of the asymptotes. Now we can determine that based on that one coordinate. It is good to get other coordinates because not all graphs behave in that way. So the other coordinate that we're going to use is we're going to use a y-intercept. So I'm going to choose a different color green here, and I'm going to find the y-intercept. And the y-intercept occurs when we plug 0 into the equation. And the easiest way to determine the y-intercept is actually from this graph here. If we plug 0 in, we get 12 divided by 15 because the x's cancel out. We could also do it in the simplified form. We get 4 over 5. In both cases, they simplify to 4 over 5, so the y-intercept is going to be at 4 over 5. It's just going to be right about there, just below the asymptote. And that confirms that that's going to be in that quadrant. Now, these are the only details you need to show. So based on these details, what we can do is we can sketch in the graph by following the asymptote through the 0, through the y-intercept, and we follow the asymptote. Now, really, to be quite honest, we don't have any idea that this doesn't go like that and come do something like that. Okay, but we don't need to. We don't need to show that if that happens. In this particular case, that doesn't happen, but there are more complex graphs where that may happen. but you do not need to show that. So I've got all those points. That's all I need to show. And the only other part I need to show is that there is another part of the graph that follows asymptotes in that quadrant. Now, how you draw that really is not that important, as long as you can just show that it exists there. Now, the reality would be that this should mirror that function on the other side, okay? And, in this case here, it does happen to mirror, but that's not necessarily always the case, okay? But it does mirror. So as long as we show something in this quadrant over here, that would be good enough.